Welcome to Train Signal. You are watching Configuring LAN Connectivity. So in this lesson, we're really going to start doing the network configuration. So this is mainly working on the interconnects and connecting those guys up to an upstream physical switch, maybe core, distribution, wherever you're going to connect this into. So we will be talking about how to configure the interconnects, how to configure the ports on the upstream switch, and some things to keep in mind when you do this. So we'll start with discussion again on the Fabric Interconnect switching modes. We've talked a bit about this, especially in the architecture section, but I wanted to go through it again, and we'll talk about, or look at where you're going to be able to set and change that setting should you actually need to do that. Then uplink switch configuration. We'll go through the steps and what you normally do to configure the uplink switches. Then using VLANs. This will be a quick refresher on VLANs, but also talking about how we configure those on the interconnects, whether they're global, whether they're local to one fabric, and things to watch out for, say, configuration again on those upstream switches. Then configuring the upstream switch ports. So we'll give you some examples. We'll go through and we'll do a couple of labs, one on a Cisco Nexus 5000 and one on a Cisco Catalyst using iOS, so you can see the slight variances in the commands when we want to configure ports that are linked to the interconnects. Next, using Vnix or virtual NIC. So we'll talk a little bit about those, especially as they equate to the VIC cards, the Palo card, the M81KR, and the new VIC 1280. A quick discussion on MAC address abstraction. We'll hit this a lot harder in the pools lesson later, but you need to understand kind of how this works within a UCS environment. Then, using and configuring port channels. So port channels were kind of a new feature released in later versions of UCSM. We'll talk about how you can take those if you have multiple connections from the interconnects to upstream switches, create port channels. Then, configuring pin groups. Pin groups allow us to pin I/O ports or Vnix on a server blade to specific uplinks from the interconnect, and we'll show you how to configure those. And finally, network design considerations. So just a couple of things to keep in mind when you're linking up to the switches, when you're doing your configuration, and just want to make sure that you're planning ahead for the future. So let's get started. So are the interconnects switches? And we've already talked about this. We've kind of gone through this, a good bit. But thing to keep in mind, they're two top-of-rack devices that connect UCS to the rest of the world. They do provide network switching. They do provide fiber channel uplinks to storage, and there's no switching done in the UCS chassis itself. So the I/O module or the FEX, again, is not a switch. If you have to send something from one blade to another blade in the same chassis, it goes up to the interconnect, does the switch there, and comes back. So they are switches, but in the standard mode, the default mode, they don't run things like spanning tree. So the FIs of the interconnect can operate in one of two modes. By default, in 99.99% of configurations, we operate in Ethernet in host mode. Again, this is like the upstream switches see this as a host with a lot of MAC addresses. If you're used to VMware, even Hyper-V or Xen, it's kind of like that. So those guys have virtual switches on the virtual host, but they don't act like a switch. They don't run spanning tree. The network just sees it as a host with a lot of MAC addresses, for each of the virtual machines. Think of the same thing here. And then you have Ethernet switching mode. This is where you can turn these into a functional but limited switch. You can cross-connect these for data if you want, but you're going to take other things on like spanning tree configurations, blocking ports, and it becomes more complex. Kind of the anecdote that I was told from Cisco was when they were first putting UCS kind of in beta sites, all the network guys wanted switching mode. They only had end host mode to start. And they said, we want switching mode, we want switching mode. So they said, okay. So they added it. So people enabled it. They saw what the downsides were, and every one of those original customers flipped back to end host mode. And we'll probably talk about this a bit more, but of all the people that we've done implementations with, 0 are running in switching mode. They're all running in end host mode. So that's the default, and that's by far the most normal deployment. End host mode, again, it should almost always be used. FIs appear to the network as a host with a lot of MAC addresses. It's like a switch, but it's not a switch. Does not run spanning tree protocol. That's a good thing. Far less network disruption or concern. What I mean by that is you don't have to worry about spanning tree kind of doing its learning process and blocking ports, and when it sees a topology change, your interconnects are not going to be affected. All links are used due to no blocking by the spanning tree protocol. So if you're not real familiar with spanning tree, Spanning tree's purpose in life is to keep loops from forming on a network. So let's say we have a network of 3 switches. Switch 1 is connected to 2, 2 is connected to 3, 3 is connected back to 1. A host on one of those switches sends a broadcast out, which floods out all ports on switch 1, hits switch 2, floods those out to switch 3, he floods those out back to 1, and on and on and on. If you have multiple links between switches, you can actually have one frame turn into 2, 2 into 4, 4 into 8, 8 to 16, and you end up with what's called broadcast storms. So spanning tree does some things. He basically sends out some special packets or special frames and looks for loops in the network. So if I send one out, port 1, and I'm a switch and I see that same frame come back in on port 3, I know there's a loop in the network. And what they do is they do an election and they come up with what's called a root bridge. And the bottom line is through a process, ports are actually put in a blocking state so they don't pass traffic to stop loops from forming. It's good because there's no loops. It's bad because, well, I just shut down connected ports. And they'll come up, should the one that's left up fail, they'll go to backup ports, but still you're not getting your best use of resources. So no spanning tree and no blocking on the interconnects when in host mode. Another thing is in host mode, the interconnects only learn server-facing MAC addresses, which reduces load on those interconnects. And what I mean by that is the interconnects look down at the chassis and the blades and say, and when a frame comes up from one of those guys to get passed out to the network, he notes the MAC address. So he knows the MAC addresses of all the blades and the virtual machines and all that stuff below. He doesn't need to learn things on the network because if it's not a server blade MAC address, odds are it exists on the network. Therefore, I don't need to learn those things. I just send them up an uplink and everybody's happy. So less load on the interconnect. And the 2 fabric interconnects again are not connected for data, only for management cluster connections. And I know I've said that probably 100 times already, but it's an important distinction, especially when I talk to a networking team and they want to know about, what about loops and what about this? No, it's not data connection, it's management only. Couple of things to keep in mind. Network traffic going from one blade to another on the same VLAN and fabric is switched locally. What I mean by that is if I have a blade in chassis 1, port 1, and he's sending something to a blade 2 in chassis 1, port 1, and they're on the same VLAN, it'll go up to the interconnect and the interconnect will switch it and send it back down. If they're on different VLANs, well, that's different IP address space. So we would have to go up to a layer 3 device. Right now, the interconnects don't do layer 3. The 6200 series are layer 3 ready, just like the 5500 Nexus switches. We can put a layer 3 module in those. Eventually, you'll see that functionality exposed on the 6200s. It's not there yet. So right now, if it's on the same VLAN, same fabric, it's switched locally. If I'm a blade in chassis 1 on port 1, which is connected to fabric A, and I want to send something to blade 2, even in chassis 1, but it's connected to port 2, which is fabric B, that means he's going to send it up to fabric interconnect on A, and since A and B are not cross-connected, he's going to have to send it out to the rest of the network and back in the other fabric. That's why I've said earlier, and we'll talk about it again later, you want to make sure you're not doing that unless you absolutely have to. So don't send things cross fabrics unless it's a requirement for some reason. Servers are pinned to one of those uplinks, so it's an automatic or manual process. And what I mean by that is, let's say you have, again, server 1, port 1. By default, when he comes up, he is pinned to one of the uplinks out to the rest of the network. So if you have 8 NICs, 8 10 gig connections to the rest of the network, the interconnect will kind of load balance across those 8 and spread the 8 blades across all 8 of those interconnects. What you can do is do automatic or manual. So you can let him decide, or you can do manual via what's called a pinning group, and we'll show you that later in this lesson. Also, it can be pinned to a single port or a port channel. Port channel is usually the recommendation, and we'll also take a look at configuring those in this lesson. So if I have 8 NICs again, going to a switch, or 4 to one, 4 to another, then we can bundle those multiple connections into a single port channel. And instead of pinning a server to a specific uplink, we pin it to a port channel. You get better use of resources because now I can distribute load basically, through different hashing mechanisms like MAC address or IP or all these other things, and distribute connections across that bundle of uplinks. Another good benefit of using a port channel is if I pin to a specific port and that port fails, module fails, cable fails, whatever, I have to repin. Now that's an automatic process. It's a slight disruption though. I mean, it does take a little bit of time You might drop a frame or two. With a port channel, it's instant because nothing has to be repinned. As long as there's a surviving link in the port channel configuration, it'll just keep working just fine. So there's a lot of good reasons that we use port channels now. Traffic received by an interconnect for a server is forwarded on if the traffic arrives on the pinned uplink. So what I mean by this is, again, let's say I've got 8 links from an interconnect up to the network. Server 1 is pinned to, let's say, uplink number 4. So server 1 is pinned to uplink 4. If a frame destined for server 1 comes in on uplink 4, it is sent down to the server. If a frame comes in destined for server 1 on uplink 6, it is dropped because there's a problem. It's called a reverse path forwarding check. It means somewhere upstream there's an issue because the switch, the upstream physical switch I'm connecting to from the interconnect, should only see my server's MAC addresses through the pinned uplink. So it's not going to send it down again because what may happen is it may have gotten flooded out on that upstream switch, and I may see it on all 8 or all 4 uplink connections. And if that's the case, I don't want to deliver 4 frames to the server. He's only going to deliver it on the pinned uplink. If it's a port channel, same thing. As long as it comes in on at least one link of that port channel, it will be passed down. If traffic is received on a different uplink than the one pinned to the server, it is dropped. So known as deja vu check. Basically, we don't want to create loops. So if we send something out and see something come back on a different uplink that we sent, it is dropped. It's a deja vu check. We've already seen this before. We saw it on the way out, or we saw it on another uplink. But again, these are protections against creating loops in the network since we're in host mode and we don't run spanning tree. Very similar, again, to a virtual switch on a virtual server such as a VMware server. So here's a couple of forwarding rules, just kind of understanding how the interconnects do traffic in host mode. So let's say from a server, I get what's known as unicast traffic. That means it's destined for a certain MAC address. So from a Blade server, I get something that I don't know. Basically, unknown unicast means I get a frame destined for a MAC address. I don't know where this MAC address lives. So if it came from the server, what am I going to do? I'm going to flood it to the other servers and to its pinned uplink. Basically, I'm going to push it out to almost everywhere. I'm going to push it up to the network and push it to my other servers. If I get unknown traffic from the network, what am I going to do with it? Well, I'm going to drop it. Why? Because we learn the MAC addresses of the blades and things underneath us. Therefore, we don't flood and we just drop the traffic. It's one of the benefits of not having to learn MAC addresses everywhere. Keeps load off the interconnect. If it's known unicast, meaning it's a MAC address I know of from a server, he sends it to the learn link. So if there's a bunch of links up or to another server and I know where it goes, I send it out that way. If I receive a frame from the network and I know the MAC address, that means it belongs to one of my blades or VMs or something behind it, and I'll go ahead and deliver it. Multicast depends on IGMP for most things on known multicast. Basically, if I see multicast traffic and I know about it, then whatever IGMP tells me to do, whoever's a member, whoever's set to receive that traffic, I'm just going to do what I'm supposed to do. Unknown multicast, if I see it from a server, he's going to flood it to the server in the pinned uplink, very much like unknown unicast. I don't know where to send it, so I'm going to do my best effort to deliver it everywhere without causing loops or duplicates. From the network, he's going to flood it down to the server links, and that's a little bit different than unknown unicast, but multicast being kind of a contained broadcast type data flow, it may be destined for a server, and we're not sure that he's a member of and has a multicast address, so we're just going to flood it to the server links. Broadcasts. So if a server sends a broadcast, he's going to send it again to the server links and to the uplinks. It's got to go everywhere. From the network, it's going to flood down to the server. So if you get, say, an ARP or some other type of broadcast from the network, we're going to go ahead and flood it to the servers because someone may need to reply. So what I want you to get out of this, simply is the interconnects learn the MAC addresses of things underneath them. And if it gets something that it doesn't know about, that means it doesn't belong to something underneath them, and it'll drop it. That's really what you need to get out of this. Everything else is pretty simple. Also understand that broadcasts still get flooded down to all the servers. So just to reiterate that, unlike true switch, FIs do not learn MAC addresses from the network. They only learn them from the servers. They have no need to know them outside of UCS. Learned MAC addresses do age out. Originally there was no MAC timeout, and it caused some issues in some long-standing environments. So now the default, I can't remember what it is off the top of my head, but it's a very long time for MAC address aging on end host mode. Server MAC addresses can move between uplinks and interconnects during a failover. So that's absolutely correct. If I'm pinned to uplink 1 and uplink 1 fails, I'm going to be repinned to, say, uplink 2, and the MAC address for that blade is going to be moved from 1 to 2, and it'll send out what's called a gratuitous ARP and let the upstream switches know it is moved. If an entire interconnect fails, then those MAC addresses, depending on if you have hardware failover configured, will float to the other fabric. Server MAC addresses can be statically configured. We'll talk about that. Most of the time we pull them out of a pool, but you can statically configure them so you'll know exactly which MAC belongs to which server. Then you have Ethernet switching mode. So I keep telling you not to use this, but I'm going to talk about it a little bit. So the other setting is Ethernet switching mode, and we'll see where we can change that setting in UCS Manager. When you change the setting, it's going to reboot the interconnects. So you can't just kind of do that on the fly. Makes the interconnects operate as more like a standard switch. Again, spanning tree protocol, and uplinks will be blocked. A big problem here is that you can't configure a lot of things when you use switching mode. So you don't suddenly end up with a Nexus 5000 or 5500. You can't set a lot of things on spanning tree. You can't set a lot of the underlying functionality. You're still limited to what you see in UCSM, which isn't much different than what you see in end host mode. So you don't get to pick and choose a lot of things. That's why it's not a great solution even still, so we don't recommend that. So recommended not to use it. There were a couple of use cases for this. Some things where I want to connect in a NAS storage, NFS, ISCSI, CIF, something like that, directly to an interconnect. So there used to be some reasons people wanted to do switching mode. Now we have other things to allow that functionality while still using in host mode. So again, anytime I've talked to somebody where they're considering this, we look at their design and see what the requirements are, kind of the constraints that are leading them down that road. And usually, in fact, every time I've done it, we have come out using in host mode, and they're much happier with configuration. So the only time it makes sense if it's a requirement to cross-connect fabrics. Again, I just don't see that as an option. If you're cross-connecting fabrics because you're sending so much traffic cross-fabric, we need to kind of redistribute your I/O and redistribute your Vnix and things like that and get things on the same fabric. We're not even going to really cover this configuration. Really, you turn it on, hope spanning tree does its job, and do a little bit of configuration, but it's not worth it because it's highly recommended you don't do this. So what do I do for my uplink switches, my upstream switches, as I sometimes call them? Basically, your interconnects are going to connect up level to the rest of the network. Now, you can cross connect these. In fact, it's recommended. So Fabric A interconnect can go to, if you have 2 core switches, you'll connect it to both of them, and Fabric B, you'll do the same. So you can cross connect these here. It is highly suggested that you use more than one link to each side. The reason for that is that I just want to make sure that a single port, going down doesn't cause things like fabric failovers. So even on very small implementations, we will do a minimum of 2 and 2 on the interconnects, just to confirm. If you do multiple links to upstream switches, I suggest you use port channels, and we'll talk about those configurations. If you use Nexus switches at your upstream, 5000s, 5500s, 7000, something like that, you may want to look at doing virtual port channels, VPCs, which allow you to do a single port channel from the interconnects viewpoint to actually 2 separate switches. You can also do that with, say, a Catalyst 6500, what's known as VSS mode. So it gives you better control and faster failover should a switch fail or something like that. Kind of outside the scope of this, but that's a recommendation that that you should probably do. Cisco has some good reference architectures on that. Very simple, architectures and configurations for how to set those up. So the first step in connecting UCS to the rest of the world is configure the existing switches. So to do this, you normally perform the following tasks. And this really goes across all switch types. This doesn't have to be Cisco, though I'm going to use Cisco as examples just because that's what I've got in my lab and that's what we, is the market leader, etc. But follow these similar things along other switches, HP, Nortel, whatever. So what you're normally going to do is you're going to configure the interface to trunk mode, because we're going to trunk down multiple VLANs and we want to tag things, so we're going to do trunk mode. We're going to configure them for spanning tree port fast trunk. Basically, this tells spanning tree on that upstream switch that, look, this is a trunk port, but it's going down to a device that's not really a switch. So bring this link up fast. Don't go through the normal blocking and learning and all this song and dance that you normally do. That way, if a link should, blip, or we unplug and plug a cable, it's not going to take 50 seconds or so to bring that guy online. We're going to specify the VLANs to trunk. Best practice says only trunk the VLANs you plan to use. Real world implementations shows that most people just say trunk all, and then we'll worry about it later. But that's up to you. Normally I say only trunk what you need. Then if you're going to use port channels, and you probably should, create the port channels and add the interfaces. Port channels must be LACP active mode. Your upstream switch, LACP is pretty much supported across the board. You're going to turn on LACP active, and they'll initiate the port channel configurations. Uplink switches must trunk VLANs to UCS. So, even if you're only going to use VLAN 1, you're really going to want to tag and trunk everything, because odds are you're not just going to use VLAN 1, so you're going to want to trunk VLANs to UCS. Cisco switches are not required. I mentioned that a second ago. We've done many implementations on non-Cisco switches. Just because it says Cisco on the front of the servers doesn't mean you have Cisco upstream. Again, my examples will be Cisco, but it's not a requirement. I say here, may need to use pin groups if connecting to separate layer 2 domains. Basically, say you have a production network and a physically separate DMZ network. This is not really true. There were some issues mainly around how UCS does broadcast. I hit on this a little bit later, but if you're in this configuration, you really want to use UCS M2O and later, because they support what is known as disjointed layer 2 networks, meaning I have a DMZ network physically separate from production. DMZ may be VLAN 50, production may be VLAN 60. You need to make sure they're separate VLANs, not overlapping. You can't have 50 and 50, but it is fully supported in UCS M2. So don't use pin groups. If you need this support, go to UCS M2. VLANs. So I keep using the term VLANs, hoping you know what it is, but basically VLANs are virtual networks. So if I have a switch, I can segment that into multiple virtual switches, and I can have a port that actually carries 10, 20, 30, 40, 100 different virtual networks over the same link. Most server administrators are very familiar with VLANs already. UCS uses those because we want to trunk multiple networks in and out of the chassis and the interconnects, and we do that using VLANs and trunking. UCS comes configured with VLAN 1. VLAN 1 is the default VLAN for everything Cisco, and really everything. It's highly suggested you don't actually use VLAN 1. Don't run data over it, don't run things over it, use it for management functionality, things like that. So we will go and create all the additional VLANs we need. When we create a VLAN on the interconnect, we have a couple of options. Most of the time, we create them globally, meaning if I create VLAN 5, I create it on Fabric A and Fabric B. That way, if there's a failover from A, we still are reachable through B. There are kind of odd configurations where you may want to say VLAN 5 exists on Fabric A and VLAN 6 exists only on Fabric B. Those are fabric specific, or what is known as local VLANs. Again, 99.99% of the time, VLANs are configured globally, but we'll give you examples of those later in a lab. So here is a quick kind of walkthrough summary on a Cisco Nexus configuration, 5000, 5500, 7000, running NXOS. So a couple of things that we need to do. First, we do a show feature command. Why? Because on NXOS, not every feature is enabled by default. It's one of those things to kind of reduce resources, and a bug in something you don't want it, that you're not even using, is always makes for a bad day. So we want to do a show feature and make sure LACP is available. If it's not, use the feature command and turn LACP on. We want to go into configure terminal mode. That just enters configuration mode. You want to type interface Ethernet 1 to select an interface for configuration. Actually, if it's say a 7000, it may not be Ethernet 1. It depends on your modules. But interface Ethernet module / interface number. Usually give a description. I like descriptions. Usually they get set on day 1, and by day 360 something else is plugged in there, the description, but I like them. So go ahead and do a description of UCS Fabric Interconnect A or B, and the port that you're connecting the other end of that cable to on the interconnect. If you are using port channels, you'll do like channel group, port channel number, mode active. Pick an unused port channel number and then enter it there, and make sure to set mode active. Remember, LACP has to be active. Switch port mode trunk says this is a trunk port, not an access port, which means we're going to tag VLANs. Spanning tree port type edge trunk tells spanning tree this is an edge port, meaning we're actually going to a device even though we're trunking VLANs and it's not another switch. So when spanning tree kind of does its thing and recalculates a new topology, we're not going to take these ports offline. Allowed VLANs all, or give a list. Here, when we say which VLANs are we going to allow to be trunked to this connection. Again, most people just say allowed VLANs all. But if you're following best practices, you're going to say allowed VLANs, 5, 10, 15-20. Just give it a list and make sure that you do that. The downside is every time you want to trunk a new VLAN down, you're going to have to create it on the interconnect, and you're going to have to go back into the switch configuration and add it there. Here's how you do port channel. So let me flip back real quick. This is everything you need on the port itself. Actually, usually multiple ports, but this is the full configuration. And now that you've created your port channel in the previous slide, you'll do interface port channel, whatever number you gave it a second ago. Again, do a description, such as port channel for UCS Fabric Interconnect A. We're going to set this port channel to be a trunk port. We're going to set it also to be an edge trunk, just like we did. And we're going to give it the same VLAN list we did in previously. So you want to do that in 2 places. Once you do that, you're done. Everything's good. You added all your ports in the previous slide, so you're just setting configuration on the port channel. So let's give it a shot. I'm going to SSH into a Nexus 5010 switch in my lab. These will not be the ports I'm actually connecting some of my gear to, just because I don't want to take that gear offline right now. But the configuration is all the same, and I'll show you how to kind of check and make sure the ports are good and everything comes up. So we're going to configure ports for UCS connectivity, as we just saw. We're going to create a port channel and add ports to the port channel. And really, we're not going to do it in that order. If you just saw the slides a minute ago, we add the ports when we configure them. But we'll go through the configuration there. So let's go ahead and get started and jump over to the lab. I'll be using PuTTY, and we'll be using the Nexus 5010 that I have in my Charlotte lab. Go ahead and expand this window so we can see. It's admin with my password. And here we are. Do a show version. And this is a Nexus 5010, 20 by 10 gig, running 413 in XOS, which is an old version of NXOS, but it's a lab. I'm allowed to do that, and the commands are the same anyway, so we're all good. So a couple things. First of all, we need to do show feature. We want to make sure that LACP is enabled. So let's do show feature. And you have to do this on Nexus because, again, some things are not enabled by default. So LACP, we have it enabled. If it wasn't, you could just go into configure mode, and you'll see me use tab completion a lot, and type feature LACP. So let's go ahead and do a show interfaces or interface brief. And I'm going to pick 4 interfaces to play with. Scroll back up. See at the top, we've got our fiber channel interfaces. If you haven't seen a Nexus, it's kind of like a 6100 interconnect, actually. 5010 is like a 6120. Over to the side, I've got a module slot with an 8-port fiber channel module. And then here, I've got my standard ports. So let's see. I'm going to do 9, Ethernet 1, 9 through 12. Those are down. There's no SFP, so I'm not going to hurt anything. Those will be good example ports. So interface, Ethernet 1, 9 through 12. And so if you've used iOS, you probably have seen the interface range command. Within XOS, they've simplified a lot of things. You can do things like run commands straight when you're in configure mode without doing do. You can type where to see where you're at, and all sorts of neat little things to make it just easier to use. So there's no range after that. So just interface E1, 9 through 12. Then I'm going to set a description, and since I'm doing a bunch of ports at once, I can't really say what it's connected to on the other side, so we'll just say UCS Fabric Interconnect. Let me check and see what's unused as far as a port channel number, so show port channel summary. 10 and 100, so we'll choose something else. So channel group, and this is going to create the port channel when you type this in. And since I'm already matched up to 4 ports here, it'll dump all 4 of them in the port channel, so we'll do 50. And make sure you set mode as active. We'll set switch port mode trunk, and these commands may not work right. Let's see what happens. Yeah. So some of these commands are going to kick back because we're in a port channel. If you're not doing port channels, if these were discrete uplink ports, we would be using switch port mode trunk, spanning tree port type edge trunk, which it does let me do on each individual port. It's just going to warn you not to connect in a hub, concentrator, standard switch, bridge, etc. The interconnects are not a standard switch again. They don't run spanning tree. They don't have loops, so you're fine, but just a warning. And then there's the switch port trunk allowed VLAN. Yeah, that's right. Sometimes I type VLANs. I got to make sure it's allowed VLAN. And you can do a range. So you could say 1, 5, 10 through 20, 45, or 56. I'm just going to do all. Again, I'm allowed to do things in a lab that you probably shouldn't do in production. I suggest you kind of split those out and denote exactly which VLANs. And again, it's going to complain because I'm in a member of a port channel. So it's basically going to ignore that. So now let's go ahead and configure the port channel itself. So if we do show port channel summary, we'll see that number 50 has been created. And here's our ports 9, 10, 11, and 12. So we'll go interface, port channel. This is a short nomenclature for port channel, 50. And then we're going to do a description again, port channel for UCS interconnect. Switch port mode trunk, and it shouldn't complain. It doesn't. Spanning tree port type edge trunk. It's going to give you the same caution, but that's fine. And then switch port trunk allowed VLAN all. And that's really it. So I mean, it's not a complicated setup to do these. You just got to make sure you do it the right way. Again, I highly suggest you use port channels. So let's say you did use a port channel. We've plugged our cables in. We're bringing the ports up on the interconnect. How can we make sure that the port channel is correct? So my favorite command again, show port channel summary. What you want to see is for the port channel you created, you're going to want to see a couple things. So right now, the port channel itself is in capital S, capital D. That means it is down and it's switched. Switched is fine. Switched just means it's a layer 2 port. On a Nexus 5010, there are no other types of ports. But on 5548 or a Nexus 7000, you can absolutely do layer 3 ports. So that's fine. When you bring this guy up, you're going to want to see the D turn into, I believe it's a U. Yes, up for the port channel. Then on each of your member ports, this D, which denotes down, should change to a P, up in port channel as a member. Now, if 3 of the 4 come up, that'll tell you you've got a problem somewhere. And a lot of times if you do something like show port channel 50 detail, is it detail? It's detail on iOS. Show port channel. Nope, there is no detail. So on iOS, there's a detail command that'll actually show you kind of detail port by port what you can do. But we can do things like usage or summary, which you've already seen. But if you want to look at an individual port, let's see, show interface. Let's do port channel 50. We can do trunk. We can do status. Actually, here's a quick way to see what there's a problem. Sorry. If you do a show interfaces brief, here we're going to see issues like this. So if there's no operational members, that's going to tell me that the port channel hasn't been established. If there's one operational member, meaning one port is functioning, you'll see this port channel be up, and it'll warn you that not all the members are up. So you need to look at the individual configuration. That's one benefit of doing something like the range of port configurations at one time. If I do 4 ports individually, I might miss something. But if I do interface E1/9 through 12, I know all 4 exactly the same. So really the chances of a misconfiguration are very slim. But again, if you do a summary, show port channel, almost getting that down right, summary, you'll see, individual ports, whether they're up or down. And then we can do a copy run start and save our configuration. But that's it for NXOS configuration. In a minute, we'll do Catalyst iOS. It is very, very similar to this. The commands are slightly different. But again, I recommend you use port channels, use the range, or configure all the ports at one time, and that lets you confirm your configurations all the same. Other than that, I mean, there's not much to configuring the upstream switches. Just make sure you put the VLANs in that you want to trunk. You can just kind of shotgun that answer and say all, but you just want to make sure it's right. The other thing to check is if you're doing a port channel, make sure you set mode active on LACP. If you don't do that, you're going to have a problem. It's probably not going to negotiate LACP, so keep that in mind. But that's it for the demo. Let's jump back over to the slide deck. So if you have a Cisco Catalyst switch, 6500, 4500, 3750, 2960, something like that, something that runs iOS, the commands are a little bit different than in XOS. So there's no feature command to start, so we don't have to check and see if LACP is enabled. It's already enabled. So we go straight to config terminal for configuration mode. Then we choose the interface that we're going to configure. If we do a range, we'll do an interface range command. I'll show you that in the lab. But the example here, TE2, is a 10 gig interface on a Catalyst, I believe, is 6500. But you'll pick whatever, module or interface number for your particular switch. Then we'll set a description, just as we did before, and we'll type switch port. And switch port says use this as a layer 2 switch port, not a layer 3 port that you can do on a multi-layer switch. So we'll do switch port and enable that for layer 2. Then we need to set encapsulation for .1Q. There's a couple of different encapsulation types and standards. Some switches only support 802.1Q, but just in case, force set switch port trunk encapsulation .1Q. Then we force it into trunk mode, switch port mode trunk, and give it the list of VLAN, switch port trunk allowed VLAN, and the VLAN numbers. Next, we enable spanning tree port fast edge trunk, but notice on the right that some switches use a slightly different command, spanning tree port fast trunk. So if it won't take the one on the left, just try the one on the right. Then we enable this to be in a port channel. If you're going to use port channels, it's pretty much the same as the Nexus. Channel group, pick an unused port channel number, mode active, and again, make sure it's set for mode active. Port channel configuration is basically the same as Nexus as well. Interface, port channel, and the number to select the port channel for configuration. We'll set a description. We'll also set this as layer 2 using the switch port command. Again, we'll set the encapsulation to .1Q, force it switch port mode trunk, and then switch port allowed VLAN all, or give it a list of VLANs that you want it to use. And finally, spanning tree port fast edge trunk or spanning tree port fast trunk, depending on the switch. So it's a little bit different than the Nexus switches, but the intent is the same. So let's go ahead and jump over to the lab and we'll give this a shot. We'll configure some ports for connectivity, do a port channel again, and make sure those ports are added to the port channel. So let's go ahead and jump on over. I will load up PuTTY again. And we will do the Greensboro Catalyst switch. Remember my login, this one's slightly different. There we go. Go to enable mode and show version. So this is a 3750E running iOS, running 12.2 iOS right there. And off we go. So there's no show interface brief command here. We'll do show interface summary. Actually, that's not what I want. Show interface status. There we go. So we have a whole lot of stuff, and I'll pick 4 of them that we're not using. So let's see. G2021 not connected. So we'll do those. So we'll go to configuration mode. Actually, one thing first. Let me do show port channel. Nope, that's the wrong command. Show ether channel. Still called ether channel here. Summary. We've got 1 and 2's already chosen, so we'll use those. Make sure I remember my ports. G2021 through 24. So configuration terminal, interface, range, G20, and I just forgot, I believe it was 21 through 24. 21 through 24. Same way. So, okay. So we're ready to get started. We will do first, I got my notes to make sure I don't forget anything. Got the interface commands, description, UCS fabric, interconnect A, just as an example. We'll set that to switch port. Then we set the encapsulation type, switch port trunk encapsulation .1Q. switch port mode trunk, switch port trunk allowed VLAN. And again, you don't have to say all. We can do things like 1, 2, 5 through 7, something like that. We'll just say all. Spanning tree port fast edge. So for this one, we will do spanning tree port fast trunk. See, this is one of those switches. Gives you basically the same error we saw before. And then channel group. We'll do 10 mode active. Creating port channel interface port channel 10. That's pretty much for this. Then we'll jump over to interface. Oh, that's right. Sorry. Nexus OS is a little more forgiving. You can jump from thing to thing without backing out. Unfortunately, iOS is a little bit more picky. Interface port channel 10. PO10 is the short nomenclature for that. Give a description. Port channel for UCS fabric interconnect. Switch port. Then we set the encapsulation type again. .1Q. Switch port mode trunk. Switch port allowed VLAN all. Trunk allowed VLAN all. And then spanning tree port fast trunk to finish the configuration. So that's that. Then you're going to want to do like a copy run start to save the configuration. And if you want to look at your new port channel, so show ether channel, we can do 10 and say detail. And it'll give us a lot of information here. It's going to have each of our ports and a lot of other data. And it's going to show, if it's up, sending, active mode. Currently the state is down. Port priorities, port states, things like that. When you build this and when you plug it in and enable it on the far end interconnect, you're going to want to see these states come back up. If not, it's going to show you what the error is. And so you're going to want to look at that and make sure that everything's configured correctly on both sides. If we do summary, it's similar to what we saw on Nexus OS, which is we're going to see these as down. We're going to want to see these as P bundled in a port channel. PO10 is S and D right now, which is suspended, and layer 2 for switch port, and D for down, so we're going to want to see that come up as well. So it's really very similar to NXOS, and so follow this along the same guidelines. Make sure you choose the right one. I suggest again you use port channels and go ahead and configure those, and then when you bring them up, just make sure everything shows up as a member. So that's it for this lab. We'll jump back over to the slide deck. So now let's talk about using Vnix. And as you remember from an earlier lesson, we talked about, say, the M81KR, the Palo, and the new VIC-20 allowed you to have virtual interfaces, whereas the other adapters, such as the CNA, the Converged Network Adapter mezzanines, only allowed one interface per port. So when you boot up your OS with one of those mezzanine cards on a blade, you're going to see two 10 gig NICs, one going to Fabric A, one going to Fabric B, and two HBAs, again Fabric A and Fabric B. Now, with something like the Palo and the VIC, I can show you, I can create virtual adapters and show you 12 NICs and 8 HBAs, and each of the HBAs pointing to different vSANs, and each of the NICs pointing to different VLANs or trunking VLANs. It's very, very flexible. But there's a couple things you need to think about when you create these. First of all, do you want to use them? So you may have a Palo card and just decide, you know what, 2 10 gigs and 2 HBAs is just fine. But you may do something such as Vmware where we talk about splitting those guys up. So you may want to use that if it's supported. Which fabric do they belong to, and is failover allowed? So again, usually what we do is mirror configurations. If I do 6 NICs connected to Fabric A for some reason, it's usually 6 to Fabric B. And if it's supported, we almost always do hardware failover, which we again have discussed in an earlier lesson. We'll talk about it more when we create the Vnix and the policies, but just some things to keep in mind. And do you want to do any other special features such as integration with VMware? And again, we'll talk about that in more depth, but it basically allows you to take Vnix configurations and push them down to VMware and manage them from UCSM. The reason I'm bringing this up in this lesson is that your cabling configuration can affect the number of Vnix you're allowed to configure. So we've talked about hardware failover previously when we were talking about the mezzanine adapters. So some cards support it. So again, if I have a Palo card and port number 1 goes to fabric A, port 2 goes to fabric B, and fabrication fails. So the interconnect fails, or all the uplinks going to the core network fails, which it will then pass through down to the FEXs. It will transition that port 1 over to FEX, or over to fabric B. So yes, you're kind of lumping everything into the same uplinks, but it's going to be non-disruptive to the OS. No one's going to notice it, and it's just going to continue on just fine. So some cards do not support it. The Intel 10 gig Ethernet cards do not. The Broadcom does not. The new 2nd gen M72KR Q&E, QLogic, and Emulex do not. So I showed you the chart in the mezzanine lesson where we kind of went through all of those. Just keep in mind, should the I/O module, the FEX on the back of the chassis, or all the uplinks to the interconnect fail, the port on the mezzanine will flip to the other FEX. So you don't need to do any sort of a teaming driver on the Blade operating system. It's now supported for VM hosts as well. Earlier versions of UCSM, in a VMware environment, we said do not do hardware failover. And the reason being, and I think I mentioned it earlier, but just in case, is that when it would fail a port from fabric A to B, it didn't send a gratuitous ARP. Meaning that when it failed, things outside of the UCS environment, say the upstream switches, did not know that that port moved from one side to the other. That has been remedied. Now when it fails over, it sends out a gratuitous ARP, which updates the MAC address tables in your upstream switches. And you can enable or disable hardware failover on a per Vnix basis. So you can do some yes, some no. Again, it's completely up to you. So here's where we're talking about Vnix limitations. And I have a table in just a minute that'll kind of lay it all out for you. So the number of Vnix you can configure on a VIC virtual interface card depends on the number of I/O modules and cables. So for example, the Palo card supports up to 128 virtual devices. Each one sometimes is referred to as a VN tag. It's basically, it puts a tag on the frames, and that's how it kind of separates those virtual NICs. Some of the VN tags are used for internal functions, so you really don't get 128. You really get like 116. And I know you're thinking, but Jason, I needed 128. You know, most people don't even come anywhere close to that, so it's not been an issue. But you take 100 and say 16, and you cut it down the middle because you have fabric A and fabric B. And if we're doing things like hardware failover, you may end up with a whole 116 on one side. So just some things to keep in mind. That number applies to both Vnix and VHBAs. So you can't have, say, 115 Vnix and 115 VHBAs. It takes one for each of those. Remember, an HBA in the Cisco UCS B series world is really doing fiber channel over Ethernet, and so it still looks kind of like a network adapter. And the reasons we may want to do this are, we may split virtual HBAs up into different vSANs, or different fabrics. And so you may need an HBA on one and an HBA on the other. It's pretty common that most people only have one fabric, or at least fabric A and fabric B for storage. And so a lot of times we'll have deployments with just single HBAs. But NICs are a different story, especially with things like VMware. We may set up a VNIC to do vMotion, one to do fault tolerance, one for management, NFS, etc. And the reason we do that is that we could split that up using VLANs, but it makes more sense to do it with Vnix, because then we can put things on there like rate limiters and QoS and all sorts of stuff on the Vnix that are harder to do within the OS or VMware itself. So that's why you'll sometimes see that done. I mean, I think our standard deployment is like 6 Vnix per fabric for this reason right here. So here's the table, and this is a new table. Something to keep in mind is the note at the bottom applies with 2 interconnects. If only one is used, the number is cut in half. Most people don't use one interconnect. In fact, it's really only supported in labs, and even then it's not a great idea. So on the left, we've got the number of IOM links, IO module links, so the number of FEX links. So if you have a 2104 XP FEX, and you only connect 2 connections from each one to the interconnects, and you have a 6120, 6140, then you get a total of 28, which is really, if you look down below that, 24 Vnix. If you have a 6248, it goes to 116. Same if in port channel mode. Pretty much those two are the same. But if you have a 2208 and you use all of them, you can go up to 116. It just depends on your configuration. Really, I mean, the only time I could see this ever being an issue is if you only had one link going up and you're limited to 13. Again, sometimes we'll do 6 and 6 and 2 HBAs, but it's rare that we ever, in our deployment mechanisms, we never do one link from each I/O module out of a chassis. Again, I don't want a single port, module, cable, anything like that causing entire fabric failover. So we do a minimum of 2 is what our normal deployment. So therefore we're covered. So Vnix and VLANs. So how are they related? Well, they kind of are and they kind of aren't. So consider each VNIC to be a physical network adapter, or if it's a VHBA would be like a physical HBA. The installed OS will treat them as such. And so if you boot Windows and you have 5 VNICs and 2 HBAs on each fabric, he's going to see 5 physical different NICs on each side and 2 physical HBAs, just like you had all those cards in the Blade server. So you have to kind of match these things up. So normally the way this works is that a VNIC is normally assigned to a VLAN. You can do this 2 ways. You can say, hey, on this VNIC, VLAN 18 is set as what's called native VLAN, and it's just going to send and receive untagged frames, just like you plugged a computer into a switch and was set for an access port. Or you can say, commonly with things like VMware, hey, VNIC 3, we're going to trunk down 5 different VLANs. And as long as your operating system like VMware is set for that, it will work just fine. So the mapping is really just each one is a physical NIC, and just like you plugged into a switch, it could be an access port kind of mode or trunking and tagging. It's really up to you, and we'll see later when we build those how you get to choose that. Even HBAs actually use a VLAN. So we'll see that in the storage section, but if I'm doing, since I have to do fiber channel over Ethernet, that travels over Ethernet, it gets its own dedicated VLAN. So each virtual SAN, each vSAN, gets a matching VLAN. We'll talk about that more in the storage lesson. So a VNIC can have one or more VLANs assigned to it for traffic. Again, it can be untagged or native, or multiple tagged VLANs. And one other thing we'll actually go into in the pools lesson is MAC address abstraction. But I want you to understand this. So if I were to hand you a blade, a B200 with a mezzanine adapter on it. On that mezzanine adapter are 2 10 gig ports that each have their own MAC addresses, just like on a physical NIC that you put into a server. We don't normally use those with UCS. UCS has a concept of service profiles, and I've mentioned this earlier, but basically it's a way to abstract what's on that physical hardware so that we can move, that OS or that server from one blade to another. We shut down, disassociate service profile, associate it to another blade, and boot the OS up. And we'll have examples of that in a whole lesson on service profiles. But normally when we create a service profile, we say don't use the MAC address that's on that blade or on the mezzanine adapter. Use one that we created out of a pool, kind of a logical pool of MAC addresses. So what this does is it allows you to port that VNIC and that whole OS from one blade to another. And it also allows for failover between fabrics. If I've got a physical NIC and other issues, it makes it a lot harder to fail a physical connection over when I can just move a virtual MAC. We'll see the same thing when we do things like worldwide node names and all that with storage, but it's the same way with MACs. We'll set a pool up and we won't use the ones physically on the card. Now you can, it's just highly recommended that you don't, and we'll go more detail in this in the pools lesson. So configuring port channels, this is from the Interconnects point of view. So earlier we showed you how to configure upstream switches, and then we created a port channel. Now we need to do it from the Interconnect side. So we're going to do a couple of things in a lab in a minute. The first thing we're going to do is tell the Interconnect which ports we're going to use for connectivity to the upstream switch, and then we're going to bundle those ports together into a port channel. So it's very easy to do, and you'll see that. You can do this again with individual links and not do port channels, but port channels are, very useful and have several advantages such as faster failover, less disruption, and appears a single border interface so that you get better pinning performance. Instead of pinning I/O ports on blades to specific uplinks, we can do it to a multi-uplink port channel. Port channels again require 802.3 AD, which is LACP for negotiation. Okay. Let's go ahead and jump over to the lab. We're going to use 2 things for this lab. Real quickly, I'm going to move over to one of my live labs running UCS M2O with the 6248 interconnects. I want to show you something very quickly, And then for the rest of the lab, we're going to use the platform emulator. So first, let's jump over to the real lab. So I've already logged into UCSM here in the real lab. What I want to show you is something that is new with the 6248 UP interconnects. This is kind of important, and it also will go along with what we do later in the storage lab. But what I wanted to show you is one little configuration item here. So I've logged in, I'm on the equipment tab right here, I've chosen one of the interconnects, and over on this side I'm going to go to Configure Unified Ports. You will not have this option if you have 6100 interconnects. This is only for 6200s. But what you do is you tell the system which ports you want to use for Ethernet technologies and which one you want to use for direct fiber channel. So while any port can be pretty much anything on these UP devices, you have to tell it up front what it's going to be. Personally, I wish you could just right-click a port and tell it what you want it to be, but it's not that simple. So first we're going to configure unified ports, and it gives you a warning. This is very important. That's why I'm taking time to show you this up front. So it says to configure the Unified Ports wizard allows you to change the port mode from Ethernet to FC or FC to Ethernet. You do this and it'll say changing the port mode on either module causes an interruption in data traffic because changes to the fixed module require a reboot of the FI and changes to the expansion module require a reboot of the module. What it's saying is that you can choose on the fixed ports which is Ethernet, which is fiber channel, and also on the module, which is Ethernet, which is fiber channel. And you do that separately, but when you do that, it's going to reboot one of the devices. If you change the fixed ports, it is going to reboot the fabric interconnect, and it will cause everything on that fabric to fail, hopefully, to the other side. If you change the module, it's going to reboot the module, so any uplinks, any connectivity out of the module will temporarily be disrupted. So this is kind of like something you want to plan out early in the implementation and hopefully not change. But let me show you the GUI for this. So we're going to say yes. Now, it's a slider bar. So you'll notice right now it looks like I'm setting the fixed ports. You do this separately. So if I want to change the module, I click Configure Expansion Module. If I want to do the fixed ports, I would click Configure Fixed Ports and comes back. Each one of these has a slider. The slider doesn't configure the whole interconnect. It only configures either the fixed ports or the module. So it kind of looks like right here that I've designated everything left, all the fixed ports to one thing, and everything to the right, which is on the module, another. That's not the case. Right now, everything on the fixed port is set up to be an Ethernet port. Basically, anything left of the slider is Ethernet. Anything right of the slider is fiber channel. So if I wanted to make these last four ports here fiber channel, I would simply move the slider down, and you'll notice it changes them to a B for uplink ports. I don't want to do that because it's going to reboot my interconnect, so I will move it back over. If I want to do the same thing to the module, I click Module, and here we do have it split. So these ports here are Ethernet. These ports here are fiber channel. And you can see I'm not really a fan of this interface because of the colors overlaying the images representing the module, but you'll see P's being an uplink port channel member. So there you go. If it's lit up, I guess it's live. If it's not, it's just a port channel member. Then you've got, let's see, storage is purple, other things are blue, so it really also depends on if it's purple, if it's blue, all that sort of stuff. So for this one, this would be purple and a P, so that's a storage port. So it's kind of confusing, but this is important that you understand that you have to come in here and make these selections. So again, this is only if you have a 6200, and what you need to get is that when you move the slider, everything's done in blocks. So I can't put the slider in the middle and pick and choose ports. Everything to the right, fiber channel, everything to the left is Ethernet. So let me cancel out of that, and now I'm going to go ahead and jump over to the platform emulator. Also, real quick before I do that, you'll notice my uplink ports are all green. You'll notice like my storage ports here, even though they say type network, you'll see where it says FC port 25, that's a storage port, or FC port 216. Shows green. When I use the PE here in a second, a lot of times when I enable those ports, because there is no physical uplink, it's all emulated, those don't turn green. So I want you to get that. If you turn something on and there's a problem, you'll get your color codes here. Failure, link down, things like that. It'll tell you why it's failed in the events log or the faults log, depending on exactly why it failed. Let's go ahead and jump over to the platform emulator. Okay, finally there we are. So here's the platform emulator. It's not nearly as cool looking as my full-on lab because I have more stuff in the lab than I've even got configured here. But to do what we need to do, we'll be just fine. So normally the first thing that you want to do is start configuring VLANs. VLANs are configured in the LAN tab. So we'll click the LAN tab up here on the left. And then you have the option. We talked about this in the lesson. You can configure local VLANs, meaning a VLAN may only exist on A, or it may only exist on fabric B, or you have the option of global VLANs, which is the vast majority, which means they exist on A and B, and if fabric A fails, there's still connectivity through fabric B. 99.99% of the time, that's the case, because you don't want a fabric failure to cause you to lose connectivity to a VLAN. Configuring them is pretty much the same wizard, it just depends where you start. It kind of doesn't matter where you start, but I'll show you that. So up here on the left, we have fabric A and fabric B. On fabric A, we'll click VLANs, expand those out. There's a couple of little things here that they've already defaulted into. But to create a new one, we'll click the plus sign here on the right. So then you want to give it a name. So we'll say prod server VLAN. And you want it to be common, meaning exist on both fabrics, only A, only B, or you can even configure both fabrics differently. So like prod server may be VLAN 10 on A and 20 on B. I don't have a really great use case for that. I'm sure there are some out there, but I've never seen that actually used in production. So normally it's either common, A, or B. So let's go ahead and just do A since I'm simulating a local VLAN. But again, I could start here and say global and it exists on both. But for the sake of the exercise, let's say A. Then you want to give it an ID. What number? I'll say 110. You're going to make sure and want to trunk this from your uplink or your upstream switches down to the interconnects. It's got to be the same number. And then there's some sharing types here, which you can do things like isolated primary VLAN, really for like promiscuous mode. Again, if you're not doing things like that, just leave it as none, and it's going to create what I'd call a standard VLAN. There's also a button here for check overlap. So you can say check overlap, and it'll show you any existing VLANs that may conflict with VLAN 110. So hopefully you've got a good spreadsheet or system. This doesn't happen, but just in case someone's already created it, it will actually show you where it exists and the name and all that stuff. So we look good, nothing there. So we'll say OK. We say OK again, and successfully created. Ta-da, that's it. So it's not exactly hard to create a VLAN. If we look here, we'll see that the only VLAN 1 exists because I believe that's the only global VLAN created. Oh, actually, that is global VLANs. Let's look here. Fabric B VLANs. So there are some others here that they've created. The odd thing is they exist on both sides, but they do not exist under global. It's weird stuff with the emulator sometimes. So if you want to create one under VLAN B, here's where you view those. Click the plus sign just as we did. If you want to look at all your global or common VLANs, again under LAN, not under Fabric A or B, but off by itself, here are just VLANs. We can look at VLAN 1, and it gives you the information about it. Fabric ID is dual, that's because it's common. Native VLAN, yes, means it sends those frames down to the blades untagged, just like a Cisco nomenclature, but it means untagged. So you may have 20 VLANs that have tagging, and one VLAN that is what we call native or no tagging. But again, if you want to create one, you click VLANs, click plus, and lo and behold, it's the same exact wizard that we just saw. So again, it doesn't matter where you start the wizard, just pick the one you want and go with it. Let me test one thing here. So we created VLAN 110. I'm going to do it again, but I'm going to check overlap. And it does not show anything. Interesting. That should have popped since we already created 110. What if I did 1? Again, there's platform emulator bugs. I don't want to scare you away from the emulator. It is a good... There we go. There we go. And actually, it may not have flagged it since it was a local VLAN, but it should have because it is going to override that. So I believe that's a bug. I'll need to check that against my fully functional lab. But if it is overlapping, you'll see it here. Fabric ID dual, meaning it's a global. The name default, which was already the name, and your VLAN number. So we'll know not to do that. Okay, so that's how you create VLANs. Very simple, really easy. Now let's look at doing switch uplinks or upstream physical connectivity. So to do that, you can do it really from a couple of places. We can do it here in the uplink configuration. So uplink interfaces, we can go here and hit plus on each fabric. That's pretty neat. And pick and choose things and do stuff like that. Right click a port and you can configure as an uplink port or a server port down to a chassis. Normally though, what I usually do instead of doing it there is I go back to equipment, and you'll find that I like pretty pictures, so this definitely helps. Click the interconnect. We'll start with A. Give us a little more room. And literally we go, okay, I'm going to connect this port right here. Let's zoom in a little bit. Actually, physical display, there we go. So I'm going to connect this port right here as an uplink port. So you right click it, and it says, do you want to configure as an uplink port? Sure. Successfully changed. And if the cable had been plugged in, and this was a real example, we would have green come up. Since this is an emulator, we don't have a physical connection, it's not going to come up. But if for some reason there's a mismatch, if some reason there's a problem, you may see it go red. If there's no cable plugged in, you may see it go yellow. If it goes red, you can take a look at it, go to faults and events, and see what the problem is. So it's sometimes maybe some weird SFP error, maybe you use the wrong type of SFP, just something like that. But when you right click a port, you get to choose what it does. Now I just showed you earlier on the unified port configurations how we kind of designate one from the other. Here, since these ports in the fixed configuration are Ethernet only, we know that because they can't do fiber channel on 6100. You can only do that on the module with the FC ports, these in green. Our choices are a little bit limited. We can do server port, meaning it goes to a chassis. Uplink port, meaning this goes to an upstream switch. An FCOE storage port, which I'll talk about more in the storage lesson. And you think, well, Jason, that's fiber channel. It isn't. FCOE runs over Ethernet, so it's considered an Ethernet port. And then an appliance port. Again, I'll hit on this a little bit more on the storage side, but it's if you want to direct connect, say, a NAS SAN, say an NFS server, an iSCSI server, directly to the interconnect without going through the upstream switch. Yeah, that's storage, but that's an Ethernet port, so you would designate as an appliance port. And really, since it's kind of Ethernet related, the difference between an appliance port and an uplink port is that an appliance port isn't going to be used for things like broadcast. It's not going to be used for some things like multicast. It's only going to be used for connectivity to another end host device. So it's a special port. And there's reasons that we do that around how we trunk VLANs and things. But if you're going to direct connect SAN in, an NFS or iSCSI type of a NAS SAN in, you would use an appliance port. And I have seen this used out in the real world. A customer may have an NFS host that has 10 gig ports in it, and the only 10 gig they're going to use with it is UCS, so we'll plug it straight into the 6100s. Just be aware, we've hit on licensing some early on, that all of these ports do require licenses. Whether it's an appliance port, an uplink port, or server port, you got to license them. If we look over here at the FC ports, our choices are even more limited. We can do an FC storage port or an uplink port, and that's it. So that's how you know that that's an FC port against an Ethernet port. So again, you're going to want to do it on one. My suggestion is if you do, say, this port here, port 17 on A, we go and we do 17 on B. Make sure those match. Just for your own benefit and everybody else's, make sure those match. So there you go. So that's how you designate which ports go upstream to the switch. Now next, you're going to want to create a port channel. So let's say we've connected a couple of ports up to a core switch or a set of core switches, and we want to do a port channel. You've talked to your network team. They're like, you want to port channel these two ports or those two ports. This is how you configure that. So the easiest way to probably do that is to jump back to the LAN tab, and you'll notice under each fabric is a port channels entry or tree item. So we'll select that. We'll hit plus. You'll give it an ID. It's just going to be a unique ID each time, and then a name. So uplink
to say a 6509. Say next, and then all you do is you pick your ports. So you notice it's not going to really tell you which ones are used, which ones are active, anything like that. You just have to know from which ones you configured. So let's say we did 1 through 4. We'll move it on over. Following ports, oh, it's going to tell me they're configured as server ports. So let's not do that. Let's delete those. We will do 5 through 8. There we go. Then finish. Say OK. And we now have a port channel. So that's pretty much it. It's not hard to create a port channel. Very simple. So we can expand this out. There we go. And expand this down. So the one you want to look at is overall status. So right now it's indeterminate. That means I don't have anything plugged into it. So when you do this in the in production, you're going to want to make sure that your connections come up and your links come up and all your ports are good. Make sure that your speed is correct. So you may, if you're using 1 gig SFPs, because you can't do 10, you need to set that to 1. We haven't talked about flow control policy. We will. But you really want to take a look and make sure your status is good. And then we look at your ports. And on your other side, on the upstream switch, you're going to want to look at your port channel or ether channel configuration. And again, remember that this uses LACP. So you're going to want to look at your LACP status. Make sure all your ports comes up as what we call operational members. So if you connect 4 cables, 4 SFPs, you want to make sure you've got 4 operational members. If only 3 of them come up, you're going to want to figure out why the 4th one does not. So a port channel is still active as long as there's 1 operational member. So everything may look fine, but you're going to want to look at it. And trust me, if one of these doesn't come up, you're going to have faults and or events come in, and you're going to get, the little box of doom over here on the side. And you're going to know to take a look at that. So it's not something that's hidden. I just want to make sure you understand when you create these to look for those. To do Fabric B, it's the same thing. We would just come here, hit plus, give it another name, say Uplink 6509. And if you did what I suggested, which was use the same ports, we would choose the same ones and hit finish. And there you go. Something that's neat is go back to equipment, back to one of the fabric interconnects, general tab, and internal fabric manager. So this is a neat little kind of, I don't know, call it a GUI in a GUI or a tool in the GUI, whatever. But if you want to know about all things network related on your interconnects, this is a great little place to go. So you can look at, which ports have I not configured. So if you click here, it's going to show you which ones you have not. So like 5 through 8 are in a port channel. Those are now configured. Expansion model 1 through 4, all of them. Which ones are configured as Uplink Ethernet? If you click that, it's going to show that to you. If you want to know which ones are FCOE storage or appliance ports, it shows you that as well. So it's actually a very useful little tool for looking at these things. Say click up and good. But it's a good way to come in here and do some of these things. Also, what you can do is, let's see, ports, appliance ports, unconfigured. So you can do something like make this a server port if you want to do that, or right click and do all your options there. So it's just a handy little thing to use if you want to come in and take a look at all your port settings. Cancel back out of that. I told you also about we would check which mode the switch is in. We do that right here, and you can see Ethernet mode is end host mode, so it is not in a switching mode. FC mode is the same, end host, I'll talk about that in storage, but it's kind of same rules apply. We want to make sure that's end host. If we go down, we can say set Ethernet switching mode, and it's going to give you a big scary warning. It'll say yes, but your FIs are going to restart, which is true, they will restart. And then it's going to get all, a lot of things are going to change because now you're going to run spanning tree. You're not going to be in the simple end host mode. So you just need to be aware of that. That's why I said in the lesson, really don't recommend that you do that. Just recommend you always leave it in host mode. And if you have a need for switch mode, kind of go back and look at your design, look at your architecture, give Cisco TAC a call and tell them what your crazy plans are, things like that, and let them try to talk you out of it, just because it's not a great way to go. But that's pretty much it for this lab lesson. I think we've covered everything. We've done all the port channels, all the fabrics, showed you how to do the VLANs. If you click each fabrics right here, you can look at all your VLANs, your uplink interfaces, your port channels, any of that. A lot of this, like I just showed you, you can find in the internal fabric manager. So that's it. Let's jump back over to the slide deck. And just to confirm, let's see, we enabled network ports on the interconnects. We right-clicked and set them as uplinks. We created a port channel on each fabric and added our 4 ports to each one. We created a global VLAN 20. We created a local VLAN 30. And we confirmed end-host mode of the interconnect. So really, that's all we plan to do. And you saw how easy it was. So it's not a complicated configuration. Just make sure you got a good map of the VLANs, the ports, and your upstream switches configured properly. And that's all there is to it. Now let's take a look at pin groups. We've talked a little bit about pin groups before, but basically they allow you to point servers to specific uplinks on the interconnect. Now by default, UCS will kind of round robin balance the server blades and the I/O ports across all available uplinks. But what if you want to specify that maybe I want to dedicate 2 10 gig connections just for an Oracle server or an Oracle cluster? And so that's what you can do with a pin group. You may set up a pin group for the Oracle servers for those 2 ports, and then another pin group for the other servers to kind of do all the other ports except for those 2. So it just allows you to do a little bit of kind of traffic engineering if you want to do it manually. Most of the time we see people just let UCS do the job, but occasionally we have special cases where we want to use pin groups, and they're not hard to configure, and I'll show you how to do that right here. So this is a simple app. We're going to create a LAN pin group. We're probably actually going to create 2 more port channels first, just to kind of give you an idea of saying, okay, you got multiple port channels, how do we use those? And then we'll create a pin group and show you how to apply that. So I'll jump over. I'm going to use UCS Platform Emulator again for this, and we'll get started. Okay, we're back in the Platform Emulator. And so the first thing I want to do is I just want to quickly create another port channel, because it's not going to do a lot of good if I say, hey, look, you can do a pin group to the only available thing. So let me go ahead and do these 4, and I'll say OK, and then I'll come down and do the same thing here. Port channels. I'm not getting real descriptive with my names, I know, but it's just for demo purposes. There we go. So we have created 2 of those, and just quickly you can take a look at the ports, transport and all that good stuff. I don't think I showed that last time, but it just shows connectivity, and if there's an error you'll see a fault. And that's one thing I don't think I mentioned before. If for some reason you enable a port, say on the interconnect, or create a port channel, and it doesn't connect for some reason, it will throw a fault, and you'll see that, and it'll give you a good descriptive error of the problem. But we're good to go here. So now we've created 2 port channels again. We have a total of 4. If we scroll down, we will see LAN pin groups. There's nothing here because we haven't created them. You could also create them from that uplink manager I showed you a minute ago. It had a pane to the right side where we saw pin groups. We'll click plus, and we'll give it a name. Demo pin group. This is for the lesson lab. And then you pick Fabric A, what is my target for the pin group? So I'll expand this, and you'll have the option of the 2 port channels, and if we had any standalone uplinks. So I'll say uplink 1. And again, you can say, hey, I want this pin group to only apply to 1 fabric. You're going to need to do some things with the OSs in case of a failover situation, so normally we do it through both of them, and you say OK. And really that's it. Now you're going to say, well, Jason, how do the blades apply this? And we'll see that later when we start setting up some of the policies around things like Vnix, and you'll have a pin group policy. But for now, that's all you need to do to set up your pin group. So you could have that one and then set up a second pin group for other servers. I'll just say other servers PG. And it's a good idea to have a naming standard for all of the things that you create. You know, I know I haven't really been following that, but it's a suggestion. And for this one, we would pick. So we may have something high performance going through 1 port channel, everything else going through the second, and use 2 pin groups for that purpose. But again, it's very simple and very easy, but it's very useful if you need to do some traffic engineering. So let's jump back over to the slide deck.
So to kind of wrap up this lesson, let's talk a little bit about some network considerations. So UCS provides a very flexible network configuration. I mean, we've seen that. You can do pin groups and port channels and uplinks, individual links, VLANs globally, locally, all sorts of things. But a couple things to keep in mind. Try to limit inter-fabric communication as it must traverse the outside network, unless you're using switch mode. And again, I'm going to try to talk you out of switch mode. And what I mean by that is don't go from port 1 on one blade to port 2 on another blade, because to do that it has to go from fabric A to fabric B, and it's going to have to go up to the interconnects, up to the upstream switch, down to the other interconnect, and down to the blade. If you do that a lot, you're chewing up uplink traffic, and you're chewing up traffic in the core switch or that upstream switch. So it's just not a good idea to do. Look at how you're deploying your servers. One thing that we see a lot of is, for example, VMware. So VMware will allow you to do a vSwitch. People will take both ports, one on fabric A, one on fabric B, put them into a vSwitch and set them for active and active. And so VMware will try to balance, usually some sort of like MAC hashing or IP hashing, across those two NICs. The downside is some of your traffic is going to bounce up to the interconnect and come back as it should, and some of it is going to jump across that upstream switch like it should not. So what we normally do is do something like fabric A on all the blades will be active, fabric B will be on standby. Should A fail, everything will flip to B. So it just makes it so that everything is switched locally in the interconnect. Be aware how you deploy your Vnix and their use with the installed OS. And that's basically what I just talked about. When you deploy Vnix, make sure you deploy them so that you don't traverse the upstream network. Don't let the OS load balance across NICs and Vnix in both fabrics. Again, we just talked about that. That's why we do active and standby. And disjointed networks really require UCS M2.0. I talked about this earlier that we used to do it with pin groups, and now we're doing it with UCS M2. So a disjointed network is a network that is separate from another. So I have plenty of customers with production network and then a physically separate DMZ, sometimes multiple DMZ networks. So if you have a UCS chassis and you have your interconnects, and I want to run 2 uplinks to DMZ1, 2 uplinks to DMZ2, and 4 uplinks to prod, those are 3 disjointed networks. And we used to use pin groups for that and specify Vnix, go to certain pin groups for the DMZs. The problem is that it came down to how UCS listened to broadcasts and some other things, so it would work for a while, but under certain circumstances, servers would become unreachable. They've addressed that in UCS M2, so if you're going to do disjointed networks, you need to make sure you're running it 2.0 and preferably the latest version of 2.0. A couple other things. If interfabric traffic is making you consider switch mode, reconsider your design. And I know that's easy for me to say, but there's usually ways to fix that, especially with things like Palo and the VIC-1280. If I can carve up a lot of NICs, there's really no reason I can't do some things so that we're not stretching across the fabrics. And finally, remember that traffic comes into a server via its pinned uplink, so make sure of your upstream configuration. Should traffic source from an upstream switch that is peered to the one of the pinned uplink, consider changing the uplink. What this means is that you may have 2 core switches sitting above the interconnects. And so what happens is that a blade may be pinned to an uplink that goes to, say, core switch A. And he may do a lot of communication to a server or to a location that comes in via core switch B. So it's going to go remote location to B to A, down to the link, and down to the blade. And so you're traversing things that you shouldn't have to. And so what my recommendation is you may want to look at doing things to flip that over and pin it to something that goes to B. Just reduce the number of hops and don't cause any unnecessary traversing of traffic. Be aware of network oversubscription. We talked a bit about this in the architecture kind of lesson. Oversubscription is normal in networking. So if I've got 10 chassis below my interconnects and I'm running 4 connections each from those 10 chassis, that's 40 gigabit heading up. Actually, it's more than that. It's 400 gigabit heading up to each of the interconnects. Well, you're not going to have 400 gigabit going to your core network, right? There's going to be some level of oversubscription. So you need to look at that. And that's very normal in networking and everywhere you see it. So just be aware of that. Most of the time, a couple of 10 gig connections to the upstream switch is more than people need. They don't do as much as what we call north and south traffic as they think. They do a lot of traffic amongst the blades, less going in and out. So monitor that using either the built-in statistics in UCSM for something like SolarWinds Orion, and just make sure that you've got adequate bandwidth. And just size those uplinks appropriately. It's not hard to do, just keep an eye on it. So that was a pretty big lesson. I mean, we talked about a lot of things. We started off by talking about the fabric interconnect switching modes. And so, you've got in-host mode, which is the default in the recommendation for 99.99% of the time. And then you've got your switching mode that makes them look like, reasonably intelligent switches that you can't really set things on. So most of the time, in-host mode. We talked about uplink switch configuration, just some of the steps you need to look at when you're configuring the switches. It depends on your model of switches and who makes them has to say exactly how you do it, but Cisco switches are not required. I give some examples of Cisco's, but you can absolutely do Nortel or Brocade or any of those other guys and connect right in. Then we talked about using VLANs, the purpose of being able to have multiple virtual networks over a single cable, and how we can use those to kind of segment and separate traffic. Then some examples of configuring the upstream switch ports. So I did an example of Nexus OS on a Nexus 5010, and then we did a Catalyst iOS switch on like a 3750, showed you how to create port channels and how to configure the ports properly to trunk VLANs down to UCS. Then we had a discussion around Vnix. So you take those kind of VIC cards, those virtual interface cards, and you can slice and dice them up into virtual adapters and NICs and HBAs. But there are some things you need to watch out for, especially as it relates to the number of connections to your FECs in the back of the chassis. Then, just a quick slide on MAC address abstraction that we'll talk about in a later lesson, but we don't normally use the MAC address that's built onto the mezzanine adapter. We actually create our own MAC address pools, hand those out via service profiles, and use those instead. Then, using and configuring port channels. So we did port channels on the upstream switches early in the lesson, and then here we went into actual UCSM and did all the configuration there. After that, we talked about why you use pin groups. You may want to have server blades or ports that you want to dedicate traffic to, so you can use pin groups for that. And then finally, the network design considerations, really around things like uplink sizing, and don't traverse traffic across interconnects or core switches unless you absolutely have to. So this was a lot of stuff in this chapter or this lesson. We'll do the same thing here next with storage. And it's a lot of the same concepts. But out of this, the main things I want you to get are connecting to the network is very simple. You just enable the ports, we set VLANs, confirm your upstream switch configuration, use port channels if you can because they give you faster failover. Make sure you have LACP mode set active, and then everything else is simple. Create your VLANs. Usually you create them globally, not on each different fabric. And finally, set your port channels up in UCSM, add your ports to the port channels, and do any pin groups that you may need to do. But it looks like a lot of tasks, but as you saw in the final, or one of the final labs that we did where we did most of the work, it was maybe 10 minutes of work. So even in a production environment, unless you've just got a lot of VLANs, you're probably looking at 30 minutes, and then you almost never come back to this until you want to add more VLANs. So hopefully you got that, and then next we'll take a dive into storage. So that's it for this lesson. Thank you for watching, and I'll see you on the next one.